Students?
Yes, sir, everything is visible, sir.
Okay, thank you. Okay, let's start the new topic, categories of networks. Right. So far we have seen the evolution of data networks, and we have seen the three different switching techniques, and what are the different network topologies, are the structure of the network, or the arrangement of the networking device should be, right? So this till this we have seen. Now we will see the categories of the networks. So yeah, as we know the network and what exactly the objective of the network it is, right? So at the beginning of the class only I have told it will connect the different or the many number of electronic devices or the networking devices using the links in order to transmit the information or exchange the resources or exchange the files, right, through the link. And link can be like cables, or like we are having the different cable like coaxial cable, right? So all these things we'll be seeing in the future slides. And in the computer networks, so we are having the different types of the networks, and this categorization of the networks, right, the categorization of the networks depend upon the geographical area, means how much area the particular network, for example n1 can cover, or the second network n2 can cover. So depending upon the coverage area, we have divided the networks, right? So the very first one is the local area network. The second one metropolitan area network, and third one wide area network, and the fourth one is the personal area network. So in real time, if you see where and all these networks will be there, right? So for example, here you can see the personal area network. It will be there in a one particular room, you can see, or a very small communication range will be there. And if you see the local area network, right? So local area network, it can cover a few rooms, right? Or a building, right? And if you consider the metropolitan area network, so it can cover the complete one city. This is, you can think of a city. So man will be used in covering the complete city, and wide area will be used to cover a whole globe. Fine. So we'll see one by one in detail about these networks. Right. So very basic one, and we have been using, and currently we are using the network called the personal area network, right? So this personal area network, sorry, yeah, personal area network used for communicating the different communicating devices. For example, computers and computer devices, or computers and the printing printers, right, in a small area, like you can think of a few meters, right? And it can be used for communicating between the devices themselves, or for connecting a large network such as the internet as well. For example, the bands can be in both, like wired or the wireless. Example one is the Bluetooth, right? So usually, you want to share some pictures which are there in your mobile with your friends, right? So usually we will, switch on the Bluetooth and we will transmit the files, correct? So that is the PAN. Bluetooth is the PAN, and the Zigbee, right? the communication in a very small area. So ZigBee and the USB. So these are the three examples for the personal area network. And in real time, actually, the personal area network looks like this. So your workstation or your laptop or desktop, and which you can connect to your mobile phone or the other laptop, right? Or any other like wireless mouse also we can have, and wireless headphone, right? Or you can think of this is a printer, so printer also we can connect it, right? So these are like within a few meters, maybe you can say 2 to 10 meters, right? So a LAN is a network that is used for communicating among computers, usually within an office building or a lab or a home, right? And LANs enable the sharing of resources, for example, files or hardware devices that may be needed by multiple users. For example, the printer in the lab. Right? And it is limited in a size, right? Typically spanning. So it can start from the 2 to 10 meters to a few hundred meters, but not more than a mile. And the speed of this local area network, it will range between 10 mbps to 10 gbps, right? But this data rate, yeah, we cannot get it, but we can get it in this range only in real time whenever we send a data or the image files to the other phone using the Bluetooth, right? And in the network, whatever the organization we, I mean, the arrangement of the networking devices, right? We usually use the links, and those links can be the twisted pair, a coaxial cable, or a fiber optic cable. It will be used in the lab. And nodes in a LAN are linked together with a certain topology, and these topologies include, like last time whatever we have seen, right? The bus topology, ring topology, right? Star topology or hybrid topology, right? So this is the actual topologies using the LAN. So in this one, you can easily understand we are having the bus topologies, right? So there is a only one coaxial cable, you can say, right? Coax, and there are many number of nodes are connecting to this coaxial cable, right? And the last class, so we have seen the disadvantages of this, right? If there is suppose this user station 1 and 2 and 3, right, and 4, right? If they have the huge data, or they everybody wants to send a do a pre they want to print some file, right? Suppose all at a time they send, then there will be a congestion here, right? There will be congestion here. So as a result, there will be the loss of files, right? That's the one of the disadvantage in the bus topology. And in the ring topology, right, the same arrangement, right? Whatever the see five devices are there here, so those five devices we have connected in the ring topology, right? And the same thing we have the star topology as well as. So there is a main the central station called the hub, and the hub will be connecting to all the stations or the devices or the users, right? So the necessary environment for the LAN, so in every room there will be the router will be there, or the hub, and all the laptop or the desktop need to be connected to this central. Suppose one more laptop is there, then that has to be connected here. And this router we call the edge router, right, or the gateway. We can name it as a gateway as well, because this is the gate for the transmission of the information or reception of the information to this network. Suppose the one more guy is here, right? One more guy is here and he wants to send the information to this guy. Suppose this is the A and this is the B and this guy is the C and here is the D. So D wants to send the information to A, right? So, and this guy doesn't know where exactly A is, right? So that information will be available in this gateway, right? So this guy has all the information about this network. So this is the wireless LAN, right? Wireless LAN. So we are having the centrally access point, wireless access point. Usually we will be having in our home, right? Everybody nowadays, everybody has this wireless access point, right? So there are three most common types of local area networks are there. The first one is the cable-based LAN. The second one is the private branch exchange, and third one is the hierarchical network. Let's see the first one, cable-based LAN. So in the cable-based LAN, all the nodes are connected by a cable media and signal transmitted through the cables. Any type of a cable are used in LAN such as coaxial, twisted pair, fiber and optical cable, right? So there is a network, right? So this is like a LAN, local area network. This is the one local area network and many devices are there here, correct? Many devices are there and these devices are connected using the cable like this, right? And these cables are coaxial cable and twisted pair or fiber optics, right? Yeah, this is the actual real time scenarios where in our lab we can get these kind of scenarios, right? So always there will be one wire which will be connecting to a main wire, right? So this you can think of the your mm, uh, RS-232, right? So everything will be connected to and it will be connected to a main, what you can say the uh, router or hub, right? It could be a router or hub, right? And these are all Ethernets. These are all Ethernet, and it is in the bus topology format. So the second one is the private branch exchange. So in this private branch exchange LAN, the many branches of a company is connected by a telephone lines. So it looks like this. So we are having the different telephones, right? So PC telephone will be there and mobile workstations also, and two different telephones, right? And we are having the IP public branch exchange, and we are having the our traditional fax device, and there is a IP and an adapter also. So all these are connected in this fashion using the LAN device. But nowadays we are having everything wireless, so we are avoiding these kind of wires, or you can say the links, right? So the third one is the hierarchical network. So here in the hierarchical network, we will be connecting the media, means the transmitting media, right? The cable or the link, coaxial cable, twisted pair, or optical fiber, right? Fiber optics. Okay. So these will be used for transmitting the information. So here there is a hierarchical, so that this is the first hierarchical, and this is the second hierarchy, and this is the third. So in the first hierarchical hierarchy, so or you can see the level 1, right? In the level 1, the all the computing devices will be there. Maybe you can say this is the our desktop, right? A desktop. And if you one more, if you are connected here, the printer, right? Printers will be there, and some switch. This is the switch, and the other telephone exchange box, right? So all this is the end users. So to connect the end users to the core Ethernet switch, we are having the one more called the switch. So different kind of switch where it will connect to the different types of working stations or the devices. So I have connected only one device here, so we can connect one more device here also. So the number of ports are available here, so that many number of devices we can connect to this switch, right? And these all switch are again connected to the core Ethernet switch, right? So why this hierarchical kind of network we need to follow? Because we can easily, suppose if any fault is there here, hierarchical is not there, and we are having a huge or big network, right? And one particular system we are having some problem, maybe network, so something has happened, so we need to identify where exactly is that, right? If it is a small, we can identify. If it is a big, what to do, right? We need to follow step by step, correct? So in order to avoid those kind of issues, what we do is we will divide the or we will hierarchically divide the network, right? So the one type of network here, the complete switch will be taking care. Maybe switch A, you can say, yeah, D, switch D will be taking care, and switch E will be taking care one kind of, and switch F is taking another kind of, right? Suppose this device has some fault, then directly we can contact to this switcher instead of going to all other switches, right? So for that reason only we will go for hierarchical network. So it's very easy to identify and rectify the errors which are present in the network. So there are many LAN standards are there. So those are again depending upon the what type of what type of services the LAN has to provide. And so in 1980s, the IEEE formed a project called the 802, to help different standards. And this the 802 specification fall into 12 categories that are identify the 802 numbers. For example, 802.1, this is the IEEE standard. So actually we will be writing like IEEE 802.1, like this we need to write, right? And this standard used only for the internet working and management, right? Means providing the communication network, right? And in this communication network, if there is any fault or any errors, right? If anything goes wrong or some link has broken, right? We need to identify that link and we need to rectify it, right? So for all these functions, right, we have defined in this standard 802.11. For if you have worked some many network simulators, right, and if you go to the back end, there you will see these classes IEEE 802.11, 1111A, B, C, A, C, B, right, P. So all these are the different standards. And if you go into the code, you will get the source code of the internetworking and the management of the network, right? The second one is the 802.2. This is used for the logical link control. So this is for the data link layer. Okay, we will see what is the data link layer and all in the future slides. This is the data link layer. This is used for identifying the errors in the networks, identifying errors and correcting the errors, right? And we have one more 802.3, carrier sense with multiple access and collision detection. So for example, we are having the uh, 3 devices. Okay, I'll write D1, D2 and D3, right? And all three have to choose the same link for transmitting the data to D4, right? And if all three will start sending at a time, then there will be collision, right? So in order to avoid this collision, what we have to do, each of these devices need to detect the state of the link, right? Whether the link is free or busy, right? So if it is busy, these devices need to wait. Whenever it is free, then it has to send it. And if there is any collision detected, for example, one more device is the D5 here, right? And it also starts sending. So when this, suppose D1 is sending the data here, right, at this point, and at the same point D5 also feels that the link is free, and it also starts sending the data. So both some or the other point of time, they can come to a point here and they can get collide, right? So that is the collision. So this collision detection need to be done, right? And that collision detection, we have a standard called the 802.3. That's a carrier sense multiple access with collision detection, right? And the others 802.4 token bus LAN, 802.5 token ring LAN, and zero point 0.6 metropolitan area network, and zero point 0.7 broad band technical advisory group, and 8, 9, 10, 11, and so on. Right? So these are the standards, IEEE standards meant for the network. And we are having a few methods for the LAN transmission. So there are 3 LAN data transmission methods. The one is the unicast, the second one is the multicast, and third one is the broadcast. So I will give one by one with a clear image, so you'll get a clear idea what will be the unicast. So unicast transmission, a single packet is sent from the source to a destination on a network, right? Very clear here. So there will be a single packet. So this is the first information, and sent from the source, right? And to A is important, a destination, right? So we are having a 3 main important thing: source, one destination, and the single packet here, right? So this is the source and this guy is the destination, right? The source is sending a single packet P1. Packet P1 will be sent from S to D, right? So there is a unicast. So this we call the unicast scenario. So there will be only in one direction, S to D, that's all. So there will be no back direction. So this direction is not there. Once it is received, then if he wants to talk, then he can send the information. So the second one is the multicast. So in the multicast transmission, again consists of a single data packet, right? Sent to the specific subset of nodes on the network. So this is very important. This part, subset of a nodes. Multicast means, like for example, in our email, VIT email, right? So they will easily send a mail to all students, faculties, TRS, or non-teaching staffs also, right? But sometimes we will get only the students, only the student will receive the mail, only faculty will receive the mail, only non-teaching staff will be receiving the mail, right? So that kind of a transmission is called the multicast, means only the selected people will receive the particular message, right? So that we call the multicast. For example, here, so we are having two groups here. One is the red group, the other one is the green group, right? So G1, G2, and R1, R2, right? And this guy is the source. So source S wants to send only to the green G1 and G2, right? That's why it is there is a arrow mark from S to G1 and S to G2, right? Suppose S wants to send to R1 and R2, right? So at that time, how it will be? So this is IS, right? So G1, R1, G2, and R2, right? Then at that time, it will be like this. Source to R1 and R2 for this case. And for this case, it will be like this. Okay. The third one is the broadcast transmission. So this is like recently we have received a mail from the registrar, right? Like the postponement of the students to the institute, right? So that is a broadcast, means everybody will be receiving the information in a institute. So institute, the all the like the institute is a complete a set, correct? In terms of mathematics, if you say set is a complete institute, so institute consists of all types of people, right? And subsets are like first year student, second year student, third year student, PhD students, right? And PhD is first year, second year, like that, and faculty and non-teaching staff, right? And management and so on, right? So these are the subsets, and these all will consist of in the institute. So in this, what we do, we used to send in the multicast, we used to send to the subset of the set, right? Only for the students, only for the faculties, only for the non-teaching staff, right? In the multicast. In the broadcast, we'll be sending to all, to the complete institute, right? For example, here, right? So you can think of this as student, faculty, right? So non-teaching staff and the management. So everybody will be sending. Suppose registrar is sending the mail regarding the due to the corona, we are closing down the institute, right? So it will be sent to the all, right? So this we call the broadcast. Fine. So the types of LAN models. So there are two models, peer-to-peer and the client and the server model. Right? So in the peer-to-peer means there's a communication exists between the two entities or the two devices. For example, device 1 and the device 2. So there will be communications here between them or between these. So there will be exchange of some information peer-to-peer, right, or exchange of resources between the peer-to-peer network. So one node will be there and the another node will be there, P1 and P2, right? So there is a communication between like this at a time, and both are having the capacity or the ability same. So that we call the peer-to-peer network. And the client and the server. So some of the nodes in the network will be serving as a server, and the rest of the nodes will be serving as a clients. For example, so server, you can think of like our the NetSim, right? In our lab we will be using NetSim, right? So it's a server, right? And these are clients, maybe the faculty, student, S1, S2, S3, and so on. So m number of students are there, right? So at the first we will be sending a request, like we will be giving our username and the password, right? Then it will ask us to give the IP address, right? Then we will what we will give, we will give some IP address like 10.10.5.30, then with the port address 5053. Then we are able to access this server. Then this replies with the server like Suresh Chavan waiting for your profile, right? Like this we have received, right? Then we are easily able to access this server, right? So this we call the client and server model. Whatever in our lab we do access in a NetSim, so that is the client and server based model. So here also you can see the file server and the all other devices are there, users are there, and they all are accessing to a particular server. This is the main server, and you can say C1, C2, C3, C4, and C5, right? Everywhere we use the client and server based model only. We very rarely we use the peer-to-peer model. Okay, advantages and the disadvantages. So advantages of LAN, of course, the speed will be very high because we always, especially when we consider the wired LAN, speed will be very high than the wireless. The cost, yeah, okay, manageable because we need a Ethernet and one or two coaxial cable if you are considering the bus topology. Then security will be there, and other services like email and resource sharing can be done here. So disadvantages like expensive to install, right? So if it is a huge building, then it will be quite expensive. So that's why we need to go for the wireless LAN, and requires administrative time, and file server may fail and cables may break, right? So this is for the wired. So both. So the next one is the metropolitan area network. So as I mentioned in the starting maybe second slide or third slide, so the first one is the personal area network, for example the mobile phone, so Bluetooth. The second one is the LAN, you can consider as our lab or your home, where your father, mother, brother, sisters, all the laptops are connected to a particular device, right? For accessing the network. So that we call the LAN, wireless LAN, and the wired LAN will be in our lab. And the third one is the metropolitan area network. So this is like a complete, for example, I am in the Vellore city. So the complete Vellore city, the communication network, whatever it is there, so that complete communication network will be provided by the metropolitan area network, right? That's why they have mentioned here it usually spans a city or a very large campus, right? And it is optimized for a larger geographical area than a LAN, right? And ranging from several blocks of buildings to entire cities, right? So PAN, the range is 2 to 10 meters, right? And LAN will be like maybe maximum 1 kilometer or 1.5 kilometer, right? Like our campus is having, no, that much. And the WAN van, so it's like a few kilometers. So it might be owned and operated by a single organization, but it usually be used by many individuals and organizations, right? So in the velocity we are having the many institutions, right? And few companies are having, right? And huge number of houses are there. For all these things, no, we need the communication network, right? So for a one, so organization can distribute the this network, and it is often acts as a high-speed network in order to allow sharing of a regional resources as well. So yeah, they have mentioned like 5 to 50 kilometer diameter, 5 to 50 kilometer diameter it can cover complete, right? So it looks like this telephone company network that provides a high speed DSL to customers and cable TV network, right? So this is the one, you can say one campus, this is the another campus, this is one more campus, and this one. So all these networks you can think of, this is the one LAN A, and this is the another LAN B, right? So another LAN C, and this is the fourth LAN D. And so all the LAN. So for example, if you just consider LAN A covers like 1.5 kilometers, right? So this is 155 kilometer, 1.5 kilometers. So all these LANs will be connected using the metropolitan area network, right? So the final one is the wide area network. So this wide area network covers a large geographic area. For example, the whole country, right? India or continent, or even the whole of the world, right? So a WAN is a two or more LANs connected together. The LANs can be many miles apart as well. So these kind of scenarios, the WAN will be used to connect it, right? So whatever the scenarios we have seen here, I am thinking this is a very small distance, right? These two LANs are not much apart, right? So small distance is say. So at that time we will be using the metropolitan area network. But if it is a huge difference, the distance between the lands is many miles or many kilometers are there, then we have to use the WAN. To cover the great distances, WANs may transmit data over least high-speed phone lines or wireless links such as satellites as well. Right? So multiple LANs, or you can say the multiple MANs, right? Metropolitan area networks or local area networks can be connected together using devices, for example, bridges, routers, gateways, which enable them to share the data, right? So the wide area network is the bridge between MANs or the WANs. So this is the one MAN, if you say, for example, or just say that this is the Vellore and Chennai, right? And the, so here is the Bangalore. So this communication network connected these two, right, will be done either by using the wireless links like satellites, other speed phone lines, high speed phone lines will be used to bridge the different MANs, WANs, other lands, right? So the world's most popular WAN is the internet. Whatever we call the internet is the wide area network, right? In general, we can say internet is the wide area network, right? Yeah, you can see here. So the one particular city, A, and different LANs are there, and in the LAN we can have the PANs, personal area network. So all the LANs are connected, right? So that is the MAN, and this is also MAN, and there is the communication between the MAN and the MAN, right? Metropolitan area network and metropolitan, and similarly here. So city B, city C, and city D. So like this communication will be exist only when there is a wide area network, or you can say internet, correct? Whenever this internet is there, then only we can transmit. This guy can, suppose this guy can transmit information to this guy, or this guy can transmit information to this guy, correct? Whatever we are having right now, the video conference or the no Teams talk, right? So this is the exist because of the wide area network, right? So in general we can say like local area network will be there in a building or in one particular campus, right? And metropolitan area, so all bunch of buildings will be there, and all the bunch of building will be in one using the metropolitan area, and all these lands or the vans are connected using the wide area network, right? So there is a hierarchy from the bottom to top, correct? So that's all today's class. So anybody has any questions?